Shri Guruvayo Namaga children, welcome to our online teaching academy Ekalaiva. Today I am going to discuss exercise 2.4 question number 7. There are 18 guests at a dinner party. They have to sit 9 guests on either side of a long table. 3 particular persons decide to sit one side and 2 others on the other side. In how many ways can the guests be seated? So, solution, since 3 particular guests or persons, 3 particular persons want to sit on a particular side, either side. So one side A, another side is B, that we are considering, right? And two others on the other side B. On the other side B. Got it, children? Either side, one I consider as A, another one I consider as B for our understanding purpose. Now we are left. Totally 18 are there. In that 3 in one place, 2 in another place means remaining how many? Out of 18, remaining 13 is there, right? We are left with 18 minus 5 equal to 13. Out of 13 guests or 13 persons, we choose 6. We choose 6 for side A. In how many ways? Already 3 is there. Now we want only 3 because either side 9 only. So in 13C 6 ways. Got it, children? The remaining how many? 6 has gone from 13, remaining 7. And the remaining 7 for side B, remaining 7 for side B in how many ways? 7C 7 ways. All the 7 together sit in side B. The number of selections for the side for 2 sides is 13C6 into 7C7. Got it? Then each side how many members? 9 members. So 9 people can be arranged among themselves in 9 ways, right? 9 factorial. Now 9 persons on each side of the table can be arranged among themselves in 9 factorial ways, right? Therefore, total number of arrangements is equal to 13C6 into 7C7 into 9 factorial. Got it, children? Now, 13C6, that is equal to 13 factorial. 1 minute. 1 minute. This alone I'm going to erase. Now, the same statement only I'm going to write, right? See, therefore, total number of arrangements equal to 13C6 into 7C7 into 9 factorial, which is equal to 13 factorial divided by 6 factorial into 7 factorial into 7C7. What it is? 7C7 is nothing but NCN. NCN equal to 1. Therefore, 7C7 is 1 into 9 factorial. Into 9 factorial into 9 factorial. Right here. Into 9 factorial. Either side, each side, no? So, two times we have to put 9 factorial. Right? 13 factorial divided by 6 factorial into 7 factorial into 1 into 9 factorial into 9 factorial, which is equal to 13 factorial divided by 6 factorial 7 factorial into 9 factorial into 9 factorial. 9% can, each side of the table can be arranged among themselves in 9 factorial. While writing, you have to write 2 times because side A 9 factorial, side B 9 factorial. That is the meaning. Got it, children? Now I am going to move to next question. Question number 9. In how many ways can a cricket team of 11 players be chosen out of a batch of 15 players? There is no restriction on the selection. So out of 15, 11 can be selected in 15C11 ways. That is the meaning, right? Now you see, first subdivision, total number of ways of selecting 11 players out of 15 is 15C11. Got it, children? 15C11. How to calculate this? I gave a formula to you, right? NCR equal to NCN minus R. That means 15C11 equal to 15C4. 15C11 equal to 15C4, which is equal to 15 into, based on R, you should expand your numerator. 4 terms you have to write in the reverse order. 12 divided by 4 into 3 into 2 into 1. Right? 15 sevens are 105. 105 into 13, which is equal to 1365. 1365. We want you multiply and check. Multiply and then see 15 remaining 1, 3, 5, 0, 1. So 1365. Got it? Now, second subdivision. They said a particular player is always chosen. particular player is always chosen means we need only 11 players. One player already is selected. Remaining how many players are there? 14 players. From the 14, how many you want to select? 10. Right. If a particular person is always chosen. Always chosen. That is the second subdivision. Then we need only 10 players. Already one player selected. They reserved, right? Then 10 players, 10 players are to be selected out of the remaining how many players? 14 players because one is fixed that you have to subtract. Remaining 14 players. 15, one is fixed. So remaining 14. In that 14, we are going to select only 10. Totally 11 players, right? Now the required number of ways equal to required number of ways equal to 14C10, which is equal to 14C4. The same formula NCR equal to NC n minus R. Write it in the reverse order. That should be, the numerator should have only 4 terms. 14, 13, 12 into 10. Sorry, 11. Right. Divided by 4, 3, 2, 1. 12 gone. Then it becomes 11. 7 into 13 11s are 3 1 3 1. So 143. 21 remaining 2, 28 30 remaining 3, 7 10. 1001 ways. Right. Now you see here. 1 minute. 1365. One person already is chosen always. That means 1001 ways. The third subdivision. If a particular person is never chosen. Never chosen. That means how many players? We need 11 players. Then 11 players out of how many? 14. 11 players are to be selected from the remaining 14 players. From the remaining 14 players, the required number of ways equal to required number of ways equal to 14C11. 14C11 which is equal to 14C3. NCR equal to NC or N minus R, the same formula. Based on R, you have to write the numbers reverse order in the numerator. 14 into 13 into 12 divided by 3 into 2 into 1. Then 14 into 26. 26, 14. 4, 2, 8, 10, 6, 2. Then 4, 6, 3. Which is equal to 364. How many ways? 364. One person cannot be selected. So totally 14 members. From the 14, we are going to select 11. That can be written as 14C11. that 14C11 is equal to 14C3. Got it, children? Thank you, children. You have to go through, you have to recall the formulas on and off, then only it is easy to solve the problem. Once again, thank you, children.